Hey there and welcome. Today we're going to talk about graphing absolute value functions using HK form. So let's go ahead and get started. Alright, so the first question is, what is HK form? And HK form, or vertex form, we use them both interchangeably, is really just a little cheat sheet that works for graphing a lot of different types of functions that we're going to see over the next couple of years in math. This is the one for absolute value. It says f of x equals plus or minus a times the absolute value of x minus h plus k. And it's called HK form because of that h and k that are right in there. These are the two main components of HK form. But let's talk about each and every part of it. So first we have this plus or minus, and if it's going to be a positive, it's going to mean that our graph opens up, and if it's negative, it means our graph opens down. Which really just means that our graph is either going to look like a V or it's going to look like an upside down V. That's really what that means there. All right, our A value is very similar to when we looked at the steepness of a line for slope and we had to determine if it was steep or shallow. This time, if our A value is between 0 and 1, it's going to compress, which means that it's going to be short and fat. If it's a value that is bigger than 1, it's going to stretch, which means that it's going to be really skinny and long. So before, when we said that the slope was shallow, that's like compressing, right? It's like a little short, stumpy hill. If it was a mountain that we were climbing because it was a super steep slope, that would be a stretch. So that's what our A value does. It tells us how thick or thin our absolute value graph is going to be. Our H value is going to move our graph left and right, but not in the way that you think. If it's plus H, we're going to move to the left. You're actually going to move in the opposite direction of what you think, right? You move the opposite way of what your x tells you. And if it's minus h, we're going to move right. And then the last part of our equation is that k value, and that's what's going to move our graph up and down, and that works totally normal. So if we have a plus k, we're going to move up. And if we have minus k, we move down. Now let's actually see how that works based on the problems that we did in the last video where we were graphing absolute value using a table of values. All right, so here are the first three graphs that we looked at last time, where we had absolute value of x, which is also known as the parent function, which really just means that nothing fancy has happened to it. It's just the basic function. There's no shifts, there's no turns, there's no rotations, none of that. It's just the basic simple parent function. Our vertex is at 0, 0, and it's just simple as that. Our next graph, you can see that we had that minus 3 in k's position, right? It's outside the absolute value, so it moves with the k value. Because it's negative, it went down 3. You notice that our vertex moved down 3 spaces. That's how that works. With that next one, we had the absolute value of x minus 3, where that minus 3 was on the inside. It's our h value. Remember, it moves the opposite way of what you think. Minus h moves to the right, so our vertex moved 3 places to the right. Let's look at those last two problems that we did. All right, so for f of x equals negative absolute value of x, that negative on the outside. Remember, that flips our graph upside down. It's called a reflection. It reflected. It took it from a v to an upside down v. And then that last one, we had that 1/2 times the absolute value of x. 1/2 is between 0 and 1, so it compresses. It makes it short and fat, right? If we're thinking of it in terms of slope, it's a shallow hill, right? And you'll notice that this graph is definitely more short and chunky than the graph before it. So that's really what each part of the equation does to our graph. So let's look at a problem where we actually combine it all together, because graphing these is super quick that way. All right, so here we have that f of x equals negative 2 times the absolute value of x minus 4 plus 5. This has all of the parts in it, so we can see how it all works. We have that negative in there, which tells me that my graph is going to open upside down. Right, it's reflected. That 2 tells me that it stretches. So it's going to be long and skinny. This -4 tells me that I'm going to move to the right 4 places. And this +5 tells me that I'm moving up 5 places. So when I do that, I'm going to zoom out just a smidge. I'm going to start off at my origin, and I'm going to move to the right 4 spaces, and then up 5 spaces, because that's what it told me to do. That's what HK form told me to do. It told me to go to the right 4 and up 5. Now I know instead of my graph going up in a V shape, it's going to go down in an upside down V, and it's going to stretch. But the easiest way to think about this is to think about it like slope. It's not slope because it's absolute value, but it works in the same way. So if my slope, quote unquote, is -2, I'm going to go from my origin down 2 and then over 1, but I have to go in both directions because remember, we're making a V. And I can continue that pattern to go down 2 and over 1 for each one of those while I make my V pattern. And then I can just connect my dots and draw my arrows. And that's really all that graphing in HK form is. It's a much faster way, and the more you practice it, the easier it is. So until next time, I will see you later. Love you, bye.